This is the screencast for section 3.6, example 9. We're going to study the present value of an annuity. So in this first situation, we're talking about present value, which is a loan. I think of it as I need money now, in the present. I am using this money presently. I'm not saving up for something in the future. I'm buying it now. Present value has this formula up here. You will not need to memorize this formula, but you will need to be able to identify it. So how I remember is that this is the one with the negative exponent, and a loan is a negative amount of money. So this one refers to loans. Okay, example 9. Carlos purchases a new pickup truck for $18,500. So he needs this money now. He needs to borrow this money. What are the monthly payments for a 4-year loan with a $2,000 down payment if the annual interest rate, or APR, is 2.9%? So first of all, a down payment is a chunk of money that you take and you just give the company or person right out in front. So this $18,500 is not the amount he's borrowing. He's actually only going to borrow $18,300. So that's his PV. That's his loan value. That's how much he needs right now. $18,300. R are his monthly payments. We're trying to solve for that. Now in the numerator we have 1 minus, and then in parentheses 1 plus. I is the interest rate per period. So the interest rate is 0.029 over, and then we said this was annually, so he's going, monthly payments. Here you go, monthly payments. So that's over 12 to the negative. Now, N means the number of equal payments that he pays per year. So that is going to be, total number of payments. So it's going to be 12 payments for 4 years, which would be a total of 48 payments that he's making. And then in the denominator is still that I again, so 0.029 over 12. So again, his total value that he's borrowing is $18,300. Now, they're going to charge him interest on that, so actually, down the line, he's going to pay way more than $18,300. That's the beauty of interest. And then he's going to pay 2.9% interest, and he's going to make those monthly payments for 4 years, so a total of 48 payments. So with my calculator, I'm going to simplify the right-hand side and save that value so I can use it exactly. So I found that this simplified value was about 45.269. So I stored that as A, and I'm going to divide, because I got to solve for R. So I'm going to divide both sides of my equation by A. If you put on your piece of paper A equals 45.27, then I know that you stored it as your calculator as A, and you can just go ahead and write A instead of that whole big mess. So I got that Carlos will be paying $404.25 monthly. Not bad. It's a good chunk of money, but 2.9% for a car loan is definitely a good rate. 0% financing is definitely better, but sometimes you just need a car, so you can't wait for those good interest rates. The now try problem number 19 says find the periodic payment R of a loan with present value PV and an annual interest rate R for a term of T years with payments made and interest charged 12 times per year. So basically we're still working with Carlos's same situation. As a matter of fact, they gave us $18,000. How creative. A different rate though, 5.4%, and then T equals 6. So I'm going to set up my present value equation. So this person is looking for a loan of exactly $18,000. Doesn't say anything about a down payment now. We don't know what their monthly payments are, but we do know their interest rate that is going to be paid a series of 12 payments per year, monthly payments, for a total of 6 years. So in total, this is 72 payments of whatever this is. And then the I value, that same fraction goes down in the denominator. So I'm going to simplify this mess and then divide both sides and find out what the monthly payments are. So this person's going to be paying monthly payments of $293.24, which seems a lot less than Carlos's payments. Well, the thing is, this person has a higher interest rate, but they get to pay it over 6 years. Carlos had to pay all of his off in 4 years. Plus he had a little bit more money, $18,300 versus $18,000. Now I mentioned before that they're actually going to be paying a lot more than their loan is worth. Are you ready for this? Okay, so Carlos, his $18,300 loan, he's going to be making, we said, 48 payments of $404.25. So let's take $404.25 and multiply by his 48 payments. He will actually be paying $19,404 for his car. This person will be paying, let's see, $293.24, and they will be making, we said 72 payments. So they'll be paying $21,113.28 for their $18,000 loan. That's what interest does. It actually makes you, if you want to borrow money from somebody, you're going to owe them more than you're borrowing because they're lending you that money.